Distance measuring equipment is another type of legacy radio navigation equipment that we want to cover real quickly here. So it's often co-located with the VOR, but also maybe co-located with the instrument landing system we'll talk about next. And it has what's called an interrogate respond model. It sends discrete pulses, and then the ground station will send the same signal back, except after a fixed amount of time delay. We'll talk about those in a moment, but you can see here, this is called the X, well, you can see in the next slide, excuse me. So it'll respond, and then you just measure how long it took. You take the delay, the fixed delay so that can be calculated out. And again, this can be done with analog technologies. This wasn't done necessarily using computers at the time. And you just divide it, you get that, you measure that time, which is the propagation time, and you divide by the speed of light, which was represented by c, and you divide by 2. So there's this concept of what's called a radar mile, which is the time it takes for a radio to go 1 nautical mile and back. So you take 2 nautical miles and you divide it by the speed of light, and it's basically 12.35 microseconds. So light travels a mile and back in 12.3 microseconds, or it takes light about 6 microseconds to travel a mile. It's a little faster than you and I can go. So there's a 12 microsecond in what's called the X channel, which is what most DME pulses use. There's a 12 microsecond delay between this initial pulse and a second pulse, and these are the pulses used as an amplitude modulation signal. So we're amplituding a carrier, and then we're going to receive a carrier back, the same carrier back, but with a delay. And so that we're going to measure that delay and then subtract out. There's a fixed delay that's not shown here that's part of this, and then there's the travel time delay. So we want to get the travel time delay and then divide it by the speed of light and get the time, or the distance, excuse me. So the X channel, these are separated by 12 microseconds, and there's a Y channel that some stations have that's separated by 36 microseconds. Again, these are often at the same side as a VOR. The carrier frequencies are tied together. These are tabulated. They're not. And then I think I misspoke on the previous slide. It doesn't respond on the same frequency. It responds on a different frequency depending on what whether it's an X channel or a Y channel. So you don't have to turn off the transmitter to receive here your timing. Now you say, well, I'm transmitting, everybody else is transmitting. So each plane knows when it sent. So you get a bunch of other stuff back. You're seeing other people's interrogations and also the response pairs, but they look random to you, and so you can figure out. And I'm not real clear about this right here. I'm not. Maybe I'll hope to be able to explain it better in class. But it's each planet you can figure out your own timing. What you get back now is going to be the distance from the aircraft to the ground. So you're going to get the hypotenuse of a triangle. You're above a certain height, and the transmitter is on the ground, and so you get what's called the slant distance. And so if you want to know your actual distance to the transmitter, you have to do some trig. Your height is going to be the sine of that slant distance, and the distance to the transmitter is going to be using the cosine of that angle off that hypotenuse there.